Hello, viewers. Welcome. Let's have a little discussion on composite function. We are still on the series of the lessons on functions and relation. So, under composite function, we are going to marry two functions together. That is a function of function. So, let's consider, say, a function of f from x to y is a function. Then let's consider another function g of y, g from y to z. If we can represent this function with their element, so let's look at this function. We are saying that a composite function is more or less like a function of functions. When two functions come together, so the function that translates the element of the set x all the way to the set what z is what we are saying a composite function. So this, you can see that this is the domain of the first function of f. Then the domain of the second function g is the range of the first function. So this element has been transported or transposed to this, and this has also been transposed to this with a certain definitions, which could be a certain functional rule. So the function that assigns the element from x all the way to the set z is what we are calling a composite function. And this is normally represented by g of g, f of g, where we know this is going to be f of g of x. So this could also be written as fg. Remember, fg is not a multiplication of the function f and g. Rather, this is just the g, a function of g followed by the function of what? F, which is the same as this. And this could also be the same as f of g of what? X. Where this can also be f of g of x. So we read this as f of g of x. Simply put that the function of f is a function of g. Better still, we can say function of g followed by the function of what? F. So how do we determine the domains of each of the function? So the quick one, the domain of the f of g of x, which is a fork, is a set of all x in the domain of g. In the domain of g, we begin from g using the values of x, such that the g of x, which is now a function, is also the domain of f. As you can see, this is the x, which is the domain of this. Then if this now translates to the range now becomes the domain of this. Or better still, we can have a set of x, which will be translated into the set of g of x, where now we can also translate this into f of g of x. So this can be translated to this, and all of this will now move to this. So now we can say this will be domain of g. This is what we are having. Then this now become the domain of what? F. So we are saying that if I want to operate the function g, f of g of x, what I need to know is that I begin with the domain of what? G. So x will be operated on g, followed by the f. So now this becomes a function of function. F is a function of a function of what? G. So if I have, let's say, f of this is given to us as, let's say, x to the power 1 over 3. Then we also have g as a function of x, also raised to the power this. So if we have these two functions and we are asked to find the f of g as a function, what do? We first of all have to write this as f of g of x, meaning if this has been changed to f of x, we know this can be changed to f of x, meaning whatever the x is what I'm seeing in the operation, right? So now if I'm seeing f of g of x, it means that the g of x has to be in place of what? My x. Do we get it? The g of x, the x is the one we have as x to the power 1 over 3. So this g of x, which is now x to the power 3, have to replace what the value of x is. So if I want to rewrite this, to solve this, I am going to begin with what? F of g of x, which is what? X to the power what? 3. But we know the f of x is this, right? So whenever I see x, I introduce what? X to the power 3, and that become x to the power 1 over 3 raised to the power what? 3. So this has to be inside. Then the power of 1 over 3 will be multiplying. So this is coming from g of x. This is replacing the g of x, which is the value of x. But the whole of this is the x we are having. So we replace that, then the x will raise to the power what? 3. 1 over 3. So this is going to be f of g of x is going to be equals to x, because power of 3, they will cancel to give you this. So all we are trying to say that a composite function is a combination of two functions. So it could be a function of function. When the function is given to you, we call it as a function of g followed by the function of f. So your attention is on the end. You treat the end first before treating the beginning. So we begin with the end, then we substitute into that. We are letting the function f of x as 3x minus 2. Function g of x is given as x squared plus 2x. We are to find g of f of x. So for a start, if I have g of x of what? X. This could also be given as g of f of x, right? Meaning whenever I see the f of x, will be replacing the x in a value. So let's see. So this simply means that begin with the function of what? F of x and end with f of g. So the domain of the f function is going to be the x. The domain of the g function is going to be the function of f. So what do? This could be given as g into bracket f of x is actually 3x minus what? 2. If this have x in them, then x is replaced with this, meaning that in the g of x, your x will also be replaced by 3x minus 2, which will be given as, from here, my x is now 3x minus 2, but my x is squared. So plus 2x, with the x is also 3x what? Minus 2. I believe you get the concept. We are beginning with the function of f of x. Then we replace our x in a g of x with that value or with that expression in order to get the final answer. So this is going to be square the first, which will be 9x squared twice their product. This will be 6. So we have minus 12x squared the last plus 4. This will be plus 6x if you multiply minus what? 4. X, constant, and I'm sure this will be 0. 4 minus 4 is 0. Then I have 9x squared minus 12x plus 6x minus what? 6x. So now the g of f of x is given as this. Second question is to find what? The image of 2 under this g of f. As we can see, g of f, the image is 2. So here I only have my g equals to whenever I see my x, I'll introduce what? 2. So it'll be 9 times x, or let me use bracket. The x is going to be 2 all squared minus 6 times x, which is also what? 2. So I believe 2 squared will be 4. 4 times 9 will be 36 minus 12. And if you perform this subtraction, you have what? 24. As in finding the image of g of f of x. We get that. Or we can still solve it as an alternative method. We can begin with g of f of 2. Because if we are to write this as x, it could have been g of f of x. So first of all, I need to find what the g f of 2 is from this expression. X replaced with 2. Therefore, this x will be changed to 2 to give us 3, 2 minus 2. This will be 6, right? So 6 minus 2 will be 4. So let's go back to have g of f of 2, which could also be given as g of what? 4. Because f of 2 is actually what? 4. Therefore, whenever I see f of 2, I put 4. And in this place, whenever I see x, I put what? 4. Therefore, this is going to be 4 squared plus 2 what? 4. And 4 squared is what? 16. This will give us what? 8. And that will also be 24. So either sometimes the question begins with this and end with this, or it begins with this, end with this. So you can use the direct substitution or find the f of 2 first, which is the first function, f of 2, followed by the g of the answer of f of 2. Alright, so for this, what are we going to do? We know we are going to begin with the g of f, where we have it here. We have f of x squared plus 2x, meaning all this is now replacing the value of what? X here. So the whole of this is now going to be 3x, which is now x squared plus 2x, or minus what? 2. So we can expand this to have 3x squared plus 6x minus what? 2. I think there is no common factor, so this will be the function f of g of what? X. But we are asked to find that of 4, the image of 4 under this. So this is going to be f of g of 4 is going to be, whenever I see x, I replace with 4. Whenever I see 4, I replace with x. So 4 squared plus 6, 4 minus what? 2. This will be 16. So right here, 16 times 3 will be 48 plus 24 minus 2. This will give us 60. So 72 minus 2. and that will give us what? 70. So we can see that the f of g of 4 is 70. We can also solve this through this method. I believe you can try that and see if you arrive at the same answer as what? 40. I believe the concept is clear. This is a function of function. So composite function is just taking one function, solve it with each domain. The whole of that become the domain of another function. Alright, if this is clear, share the link with your learning mate. Subscribe if you are new. Leave a comment and like the video. Bye bye.